So we have done the properties of photon. We have done the properties of photon. We need to discuss few more terms here. One of that is your photon counts. Photon counts. Photon counts. For example, suppose there is a source. Okay, from here light is going out continuously. Light is going out continuously, and let us say the P be the power of the source. P be the power of the source. Power of the source. So here we need to understand P means this is the amount of energy, total amount of energy the source is radiating or emitting per unit time. So that is why power is nothing but energy per unit time. Okay, so here that is, and let us call energy of each photon to be EP. Energy of each photon. EP is the energy of each photon. Then we can calculate how many photon this particular source is emitting every second. Okay, for example, let us call the source is emitting the power of the source is 100. That means it is emitting 100 energy. I'm not mentioning the unit. 100 energy every second. Okay, 100 energy every second. And suppose energy of each photon is 2. Energy of each photon is 2, and the source is emitting 100 energy. Then we understand that every second the source is emitting 50 photons. Understood? Energy emitted by the source every second is how much? 100. And energy of one photon is how much? 2. So therefore the source is emitting how many photons every second? 100 photons. Therefore if EP be the energy of each photon and P is the power of the source, okay, then the number of photons emitted by the source in 1 second, number of photons emitted by the source in each second or in 1 second, in 1 second will become energy in 1 second, that is power, divided by energy of each photon, which you can write EP. Okay, if power of the source is P and energy of the photon we have already seen in the last video, energy of the photon can be written as h nu or hc by lambda. Okay, so this will be the expression of number of photons emitted by the source every second. Another point, we need to know about intensity of light. What is intensity of light? We have few things. One is energy, one is power, one is intensity. We need to understand them properly so that we do not get confused. Okay, as far as definition is concerned, intensity is defined as energy crossing per unit area per unit time perpendicular to the direction of propagation of light. For example, light is traveling in a particular directions. Light is traveling in a particular directions, and here we have a surface. For example, here we have a surface. Through this particular surface, normally every second, and through this particular surface, normally every second per unit area of this surface, how much light will be crossing, that will be called as intensity. For example, surface area is suppose A, energy which is coming is suppose E, then we can write intensity as energy divided by area divided by time. This will be defined as intensity of light. So it is defined as energy crossing per unit area per unit time, energy crossing per unit area per unit time, perpendicular to the direction of propagation, perpendicular to the direction of propagation. Here we are holding the area normal to the direction of propagation. Okay, perpendicular direction of propagation. This is called as intensity of the light wave. Yeah. So now here another point, energy per unit time, this is called as power. So intensity can also be written as power divided by area. So we have seen I is equal to E divided by area divided by time. It can be written as P. It can be written as P divided by area. What does it mean? That power is nothing but intensity into area. So let us get friendly with these equations. Power, intensity into area. Okay, intensity is what? Energy divided by area divided by time, right? And intensity here will become power divided by area. But this power is not the power we have discussed here, power of the source. This is a different power. I'll be discussing about it later. Okay, this particular area. This is the power of the radiation falling. This is the energy falling on this particular area per unit time. Two different things are there. One is for the source. One is for the source. What is the intensity of source? What is the power of the source? And another is on the surface. Okay, energy falling on the surface per unit area, that is going to be different. Okay, and energy coming out of the source per unit second, that is going to be different depending on the nature of the source, whether it is point source, whether it is a linear source. We'll be discussing that point very soon. Now let us go to that point. Suppose, let us consider a beam having constant cross-sectional area. The beam, the rays are parallel to each other, they're coming and they are falling on a surface. They're falling on a surface, right? In this situation, what will happen, right? If you consider, you can consider a surface here, you can consider the surface away also, same surface. You can consider the surface here also. Wherever you consider the surface normal to, the beam at every point will be seeing that same amount of light will be crossing per unit area per unit time. So in this situation, what will happen? For a beam having constant cross-sectional area, okay, its intensity at every point remains constant. Intensity at every point remains constant. Intensity at every point remains constant. Another point, if the source is a point source, for a point source, see this point carefully, for a point source, okay, let us assume a point source. From this point source, radiation is going in every directions, having three-dimensional symmetry. And from this point source, for example, suppose we have to find intensity at a distance r. From this point source, we have to find intensity at a distance r. And let us call P be the power of the source. Okay, we have to find intensity at a distance r. So what we'll do, considering this radius as r, we'll consider a spherical surface. We'll consider a spherical surface. लग नहीं रहा spherical, लेकिन फिर भी समझ लो, spherical surface. So we are considering a spherical surface, and from this point source, light is going and falling on the spherical surface. No light can escape without falling on the surface. जितना भी light यहाँ से निकलेगा इस surface में गिरना ही उसको. Now from this source at a distance r, we have to calculate intensity. So how to calculate intensity? P is the power of the source. That means from this particular source, every second P amount of energy is coming. If P amount of energy is coming out of this source every second, then total energy falling on this surface per unit time is also going to be P. Okay, for example, from here 100 is coming every second, then on the surface how much will fall every second? 100 will fall. It cannot be more than that, or it cannot be less than that, because light cannot disappear on the way, or light cannot get generated on the way from conservation of energy. So what amount of energy is coming out from here every second? Same amount of energy is going to fall on this surface every second. So power of the source and power on the surface is going to be the power of the source, and power on the surface is going to be the same. So if we have to find how much energy is passing through this particular point per unit area, per unit time, then we know the total power associated with this particular surface is how much? P. Then intensity will become how much? Power divided by total area. And how much is that area? P divided by 4 pi I square. So we have seen for a point source at a distance r, your intensity will be inversely proportional to the square of the distance. Okay. So similarly for a linear source, for a linear source, we consider a linear source. This is a linear source, for example. Okay, so it will be emitting radiations not in every direction, but in every direction on a, like if this is the source, then light is going to go out like this. Okay, perpendicular on a plane, perpendicular to this particular source going out. So from this particular source, suppose at a distance r, we have to find intensity. Then what we'll do? Okay, with r we will be making a cylindrical surface. With r will be making a cylindrical surface. Then we see that every light which is going out from this particular source will have to pass through this cylindrical surface. Light going on from this source, there is a cylindrical surface. Every light will have to pass through the cylindrical surface. It cannot just escape without crossing it. So that is why if P is the power of the source, then energy going out of the source every second is P. If P is the power of the source, then energy going out of this source every second is P. Then energy falling on this cylindrical surface every second, that is also going to be your P. So here also your intensity can be defined as power divided by area. But this area is going to be a cylindrical area, which we can write twice by r into L. If L is the length of the source, length of the cylinder also will be considering as L. So from here we have seen intensity is inversely proportional to distance. So if we have a linear source, okay, from the source at a certain distance r, intensity will be inversely proportional to r. If it is a point source, then it is going to be inversely proportional to square of the distance. This particular point you need to understand about your intensity. Another important point out here is there. Okay, let us now discuss about radiation pressure.